So, good afternoon, morning, evening, whatever it might be. Quick video for you about the two-step synthesis that you're going to be doing in the chemistry lab on Singleton over the next couple of weeks, depending which Wednesday you signed up for. There's all kinds of information you need, including, of course, a map of how to get to the campus. That's all loaded in there on Canvas. So what you're going to do is you're going to take this compound here, methyl benzoate, which I will draw like this in a skeletal fashion. You should all be familiar with skeletal structures like this one. If you're not, no big deal. You will have it all revealed to you, and my colleague Sanjeev takes over from teaching in about a week and a half from when I'm writing this. But anyway, this is methyl benzoate. What you need to note, and again, I'm casting back to hopefully some A-level studies for most of you, maybe some foundation studies. You have two functional groups in this molecule. You've got this benzene ring here that likes to undergo substitution reactions, and you have an ester group here that's really rather boring, and the main thing an ester group will do is just hydrolyze to cleave off the organic part here and give you the acid back again. And the two steps of this reaction are to do each of those types of reactions sequentially. So you start off in step one, you take the methyl benzoate, you react it up with concentrated sulfuric and nitric acids, and that substitutes this hydrogen here for a so-called nitro group right there. And then in step two, you take this, now you've done the reaction with the benzene ring, you're now going to do the reaction with the ester there. React it up with water with a sodium hydroxide catalyst, and you turn the ester to the carboxylic acid. Now, one of the assignments you're going to have for this lab is the three compounds here, the methyl benzoate, the 3-nitro methyl benzoate, and then the 3-nitro benzoic acid, using very old-fashioned names there. You're going to be given the infrared and the carbon and proton NMR spectra of these, again harking back to your A-level days. You should be familiar with these ideas, and you're going to be asked to compare and contrast and explain the differences between the infrared and NMR spectra of these three compounds. Now, to go into experimental details, you have the script that you're responsible for reading, and there is also a video that we put together of doing the experiment very, very quickly. So between these three things, you should be in good shape in terms of doing the experiment itself. Anyway, for step one, we're going to take our methyl benzoate and we're going to react it up with sulfuric acid and nitric acid. What you will find when you get into the lab is that we have already measured out a lot of these substances for you. So there'll be a bottle of concentrated sulfuric acid in the ice bath that already contains 10 cubic centimeters, so you don't have to measure it out. There's already another bottle that will contain 5 milliliters of methyl benzoate, and these should be cooling down for you in the ice bath when you get to the hood to which you have been assigned. Now, at this stage, one of the issues with organic chemistry, especially when you have molecules with more than one functional group, is you can have competing reactions. And what we have here is we have already an ester group with some acid, and an ester group with acid can be hydrolyzed using the acid catalyst instead of the base catalyst that you're going to do. And you can see here we'd be hydrolyzing the ester to the acid. Now, this acid here, benzoic acid, doesn't really react very well, and so if you just had benzoic acid and tried to nitrate it, you would have a very hard time doing it. So what we want is, we do not want this, we want this. If your solution goes pink at this stage, no big deal, because this is a reversible reaction. You go ahead in step three and you add in this acid mixture slowly over about 10-minute period, 1 cubic centimeter at a time. You don't want it to get too warm. But anyway, as you add this in, it will react up some of the remaining methyl benzoate, which means then that this reversible reaction gets disturbed. Some of the nasty pink stuff will go back to methyl benzoate, which you will then react further, thus having more of the pink stuff going backwards. Now, you have to do this whole experiment within the 3-hour lab period allowed, indeed the 2-hour and 45-minute lab period allowed. So we do it in an efficient, time-saving way. When you get to this point and you've added your first cubic centimeter of this acid mixture, then you can go to the other side of your nice big hood and you can start step two. So you get a round bottom flask. There will be in your hood a bottle that contains some white solid. That's the product from part 1. So again, ready weighed out, 3 grams of it for you. So you add that to the round bottom flask, 10 mils of deionized water. You will have to weigh out the 1.5 grams of sodium hydroxide yourself. Put in some anti-bumping granules, and then you set up a so-called reflux. Okay, now this is taken picture from our lab, so all of this equipment will be there. This is a hot plate, little aluminium cup into which you put the round bottom flask that is your reaction measure. You clamp the round bottom flask there at the top. You then insert into the top of that a condenser, which again you clamp nice and loosely. Now the idea of doing a reflux, which is what you're doing, is you're able to do the reaction at the boiling point of the solvent. If we just had a beaker on the bench and we heated it up till the solvent boiled, the solvent would evaporate and our reaction mixture would boil dry. With the reflux though, you heat it up, the solution boils, the solvent evaporates, comes into the condenser, condenses, drips back down again, so that you can continue to do the reaction at the boiling point of the solvent. So in other words, hot, so therefore a fast reaction without any issues. Anytime you use a condenser like this, whether it's a reflux vertically, or some of you might remember doing a distillation where the condenser is on an angle, you always connect it so the water goes in at the bottom and out at the top. You can see in pipe here connected to the tap, the out pipe going into the sink. So hopefully after about 25 minutes in the lab, you'll have both step 1 and step 2 going in parallel. Step 1, you're adding the acid mixture, and step 2, you've got the reflux. Now, when you finish the reflux, you'll have a yellow solution, and in step 1, when you finish adding the acid mixture, you'll have a yellow solution. Both of those yellow solutions contain the respective products, which are white solids. So the next step to do for both of them is a so-called crystallization. You want to take that white solid that's in solution and crystallize it out, precipitate it out, separate the solid from the liquid. And the way you do that is you cool it down. Now it's dead easy to do the step 1. Step 2, a little bit more complicated because you have to add in some concentrated hydrochloric acid solution, and there'll be a question about what is the role of adding in that concentrated hydrochloric acid solution. And in order to answer that, you just have to think back to what we talked about, acids and bases and conjugates. Anyway, either way, you cool it down and you should end up with a white solid precipitated out of your yellow solution. So now the next step is to separate that white solid from the yellow solution, which we do via filtration. Unlike what you might remember from your school days where you did gravity filtrations, we are going to be doing vacuum filtrations. So you set up this. You take a thick-walled filter flask and clamp it. You then connect a heavy-duty rubber hose, to the vacuum tap that is in your hood. You put this little rubber disc in, you put the filter funnel in there, put 2 pieces of filter in there and wet them down with a little squirt of distilled water. Turn the vacuum on, it will suck it down. And then you add in your liquid solid mixture into that and just sucks the water straight through, or sucks the liquid straight through. You don't need to wash it. Washing simply just means you add a little bit more liquid into the solid to hopefully dissolve any other impurities. First, step 1, you wash with deionized water and cold methanol. Step 2, you do the same thing, but you wash with cold water again. So now what you'll have, whether it be step 1 or step 2, so you're doing 2 separate filtrations here, you'll have an impure white solid in the filter funnel. You want to purify that, and the way you do that is so-called recrystallization. Recrystallization, you're going to do this for both step 1 and step 2, again separately. You just take your solid, you dissolve it up in the minimum of hot solvent. For step 1, if you've got the right amount of product, minimum volume of hot methanol is about 10 to 12 cubic centimeters. Step 2, minimum amount is about 3 to 4 cubic centimeters. If you have too much of your hot solution, hot solvent there, then it won't recrystallize, because what you want is, most things are more soluble in hot than in cold. You do the minimum of hot to dissolve it all up. So as that cools down, then your product will appear again. Both cases you need to filter, so you're actually going to do 4 vacuum filtrations, and then if it dries well enough, and remember you've got to be out of here before 12 o'clock, then you can measure its melting point. You will have some of our demonstrators, I'm hoping actually quite a few of our demonstrators from the chemistry department who are familiar with the lab, who will help you out with all this. And of course I will be around, and I suspect Enrico will be around to help you out. Hope you have jolly good fun. See you in the lab.